Summarising data example 13. I want to start by just having a quick look at the set of data that we're given above the table. If you look, the data is 30, 50, 20, 70, 40, 20, 30 and 60. And you will see that we worked out the mean of that data, which I think worked out to be 40. And I think the standard deviation of that data worked out to be 17.3. Okay. Now, the idea of coding is to make the data easier to work with. So above example 13, we divided through by 10. That makes this data much easier to deal with. And we worked out there that the mean came out to be 4, and the standard deviation worked out to be 1.73. In other words, if you divide the data by 10, the mean divides by 10, and the standard deviation divides by 10. So what you could do is divide all the numbers by 10, get a simpler set of data, work out the mean and standard deviation, and then just remember to decode by multiplying by 10. So multiplying and dividing are reasonably straightforward. Example 13 asks us first of all to subtract 20 and then divide by 10. So we could write that as a little formula. Whatever your x value was that you start with, take away 20, divide that by 10, and that gives us a new value which we're calling y. This is the coded value. So going back to this original set of data, if we take away 20 and divide by 10, you can check I'm doing these right, I think you get 1, 3, 0, 5, 2, 0, 1, and 4. So for example on the last one, 60, take away 20 is 40, divided by 10 is 4. So that's our new set of data. Let's work out the mean of that data. If we add up all those y values and divide by n, the number of values, we're going to get 16. When you add those up, add up all that row, divide by 8, the mean is 2. So I'll write that over here, 2. Now think about what our coding was. We coded this original set of data at the top that starts with 30, and we got this set of numbers. What will I have to do to this 2 to decode it and get back to 40? Well, I think it's fairly obvious that you would undo this calculation here by working backwards. So instead of dividing by 10, we would multiply by 10. That would give us 20. And then instead of subtracting 20, we would add 20. So 2 times 10 is 20, add another 20, gives you 40. So to decode the mean, you just work backwards. If you've subtracted 20 and divided by 10, working backwards, you would multiply by 10 and add 20. So you just do the 2 steps the opposite way round. This is where it gets a little bit tricky. We're going to find the standard deviation of y. Remember that formula. Sum of y squared over n, take the mean squared. Now, if you work out the square of each value, 1 squared, add 3 squared, add 0 squared, and so on, I think you get 56. Divide it by n, which is 8. So then take away the mean squared, the mean is 2. So take away 2 squared, and that gives you an answer of root 3, which is about 1.73 approximately. So it's square root of 3, which is about 1.7. Now, how do we decode the 1.7 to get back to that original value, 17.3? Well, you'll see that we are multiplying by 10, but are we adding on the 20? Well, obviously not. So the coding here was subtracting 20 and dividing by 10, but to decode it, we're only multiplying by 10. We're not adding on the 20. Now, the reason for that is that standard deviation is a measure of how spread out the data is. So if you imagine that we've got a set of values, a certain distance apart, certain amount of spread, if I subtract 20, all that happens is that I pick up those values and move them 20 places down the number line, but they're still going to be the same amount of spread between the bottom number and the top number. So actually subtracting 20 here, it doesn't affect the standard deviation. Dividing by 10 does, because if you divided this by 10, you would make it 10 times narrower, so that would affect the spread. So the rule is that whatever coding you do backwards to decode for the mean, but you only use values that you've multiplied or divided when when you're decoding for the standard deviation. We don't do any additions or subtractions. Okay, so that's something that we'll look at when we go on to look at example 14 in a second.